So for the remainder of section 3.6, we're going to be talking about composition of functions. A lot of times one quantity is a function of a second quantity that depends in turn on a third quantity. For example, if you think about the cost of a car trip, it depends on how much gasoline is consumed, right? But how much gasoline is consumed is a function of the number of miles you drive. Then it depends on how much gas costs and your gas mileage. So there becomes several things hooked together in a chain of events that gives you the total cost. Anytime you have more than two variables working together, it's called composition of functions. And there's kind of an easy way that we can kind of compose those and turn them into a singular function. So we want to look at that. The first thing we want to look at is notation. So if we look right here, we have f of x equals 2x plus 7 and g of x equals x squared minus 1. And you're being asked to find the function f open dot g of x. That little open dot right there is the symbol for composing or composition in math. It is not a multiplication symbol. It is a composition symbol. Now there are other ways to write it. Sometimes it's just written shorthand as fog.
What?
As fog. F little o g. Sometimes in shorthand you'll see that with a tiny o. People will just read it fog. What it really means and is said is f of g of x. That's what it's asking you to do. It's asking you to find f of g of x. And you should already be very familiar with that just because of the way the difference quotient works. Okay? So what this is asking us to do, all three of these are symbols asking us to find f of g of x. It's asking you to take your outside function and remove the variables. So my outside function is 2x plus 7, right? Take the variable out, just like you do with the difference quotient. And instead of putting x plus h there, like you would for the difference quotient, you want to put the inside function. So I want to put inside there whatever g of x is. And that's what's going to go in that parenthesis right there. So it's just a substitution process. That is f of g of x. Be very careful that you don't get the wrong one on the inside. What goes inside the parentheses is whatever was in the parentheses to start with. So g of x goes inside the parentheses. Then you distribute, and we get 2x squared plus 6. That is f of g of x.
Yeah, that's not right. You should read the 2.
Oh, I'm a terrible distributor. Thank you. That changes everything. So now you can see why I didn't make A's in math when I was a little kid. So it actually is 2x squared plus 5. Thanks, guys. Okay, there's our final answer. Other than that, we did everything correctly? Did it kind of make sense? Yes, no, maybe? Yes. Okay. Well, you take a minute now and see if you can figure out what this would be, g of f of x. I think it really helps students to think of the other notations, and the one that I can see the best is this one. So even though your book prefers those little open circle symbols, I understand it better when I can see what is inside the parentheses. So maybe that'll help you guys, I don't know. So we'll pause here and give you a minute to see if you can figure it out. So what we have f of x is the inside function. So the one that's closest to the x is the inside function, and that's the one that needs to go in the parentheses. So my outside function is x squared minus 1. So that means I keep the parentheses, take the x out, insert parentheses, keep the square, minus 1. And what goes in the parentheses is the entire inside function. So 2x plus 7. And then to get rid of those parentheses, you have to FOIL it out or square double squared. Square the first, double the product, so that'll be how many? Multiply it together and you get 14x, double it and you get 28x plus 49 minus 1. So that gives us a total of 4x squared plus 28x plus 48. So you can see the difference. They're not equal to the same thing. So be very, very careful that you do not get them backwards. Now, we haven't talked about the domain yet, and I do want to do that. Are you ready? Oh, maybe I don't want to do it yet. Maybe I want to do another example. How's that? I thought the domain was right after that. This one's a little different if you look at it. Instead of asking you to find f of g of x, it's asking you to find f of g of -2. And it gives you two totally new functions. So if you want to take a moment and jot those down, and then we'll look at f of g of -2. Because there is a shortcut you can take when you're putting in an actual number as opposed to a variable. Okay. Well, if you notice, the first thing we do here is I'm going to rewrite it because I can see it better using this notation than the other. And rather than leaving the variable as x, it's actually asking me to change the variable to a number. So it's asking me to change it to -2. So you simply take -2 and you substitute it into the inside function. So that's your first thing. First, we find g of -2. And these problems have to be worked from the inside out. So you start on the inside and then work your way outside towards the left. So we put 2, -2 squared, plus 6 times -2, minus 5. This piece right here becomes 2 times 4, which is 8. This becomes -12 minus 5. And that tallies up to -9. That is not my final answer. That is just g of -2. Now I have to take that and find f of it. So f of -9 is equal to whatever 3x minus 2 is, so 3 times -9 minus 2. And that gives you -29. That is f of g of -2. A lot of people who are struggling a little bit when you have plain x's understand that a little better. Do y'all understand the process? First you take the number, you work on the inside, plug it into the inner function, which is g. Then you take that answer, which we found to be -9, and you substitute it into the outside function. And even if you had 3 of them, you could still do that. You would just take this answer, -29, and plug it into a third. Okay, that gives us just a couple of minutes to talk about the domain of a composition. And it's just something you have to memorize. It's very weird. Basically, to find the domain of any composition, first you find what it's asking you to find. So you have to actually do the problem. You have to find f of g of x, for example. Then you find restrictions on the final answer. So first you find the function and you find the restrictions on the final answer. But you also include any restrictions from the original inner function. So basically you have to look at 2 sets of restrictions. Final answer restrictions and the original inside function, not the outside. The outside original function has nothing to do with it. The original inside function. Those are the restrictions that count, nothing else. And you build your domain from that. So you look at the original inside function and the final function. You do not ever use the restrictions of the outside original function. I know those are a lot of words, so kind of stop and think about them. Maybe we'll have time to do one.